Moving on to the exercises, we're going to read in this movie data set and just select these actor Facebook columns. Notice the title is in the index, so it's a pretty short data frame, only 3 columns. And that is good just to get the shape so we can see exactly how much data we have. So this number 1, calculate the mean of each actor Facebook column. Dot mean, which actor has the highest mean, 1, 2, or 3? Well, we can see here it is actor 1 Facebook, but you can actually chain the IDX max method. So this returns a series, and this will tell us, exactly which one has that max. The result of exercise 1 is a series of values. Can you call a method on this series to choose the column name with the highest mean? That's what we just did here. So really this was the answer to this one. You're supposed to leave this one like this. Number 3, calculate the total Facebook likes for all 3 actors for each movie. So we have actor Facebook like, if we do dot sum and we do this is the, for each actor 1, 2, and 3, we get the sum of those likes. But if we sum this up, this is a series, so we can just call the sum method again, and it will do the total like that. What percentage of movies have more than 10,000 total actor Facebook likes? So this is a little bit more challenging. So here's our original data set. What we need to do is sum each one up and then determine if it's over 5 or 10,000. So we need to not sum vertically. We need to sum for each movie, which is horizontally. I'm going to say actor access equals 1. So now we know the total for each one. We test it whether it has 10,000. That gives us a Boolean. So what percentage of these? Well, we now need to take the mean of this Boolean series, which works like this, multiplied by 100. So it's about 30%. All right, number 5, find the median gross revenue in millions of dollars for the movies that have more than 10,000 total Facebook likes. Okay, so this is interesting. Find the median gross revenue in millions of dollars for the movies that have more than 10,000. So let's just, these are the ones that have more than 10,000 total. We'll call this filter. We still have the movie data set. So we can do loc filt. This filters them out. Just these are the ones that have more than 10,000. But we want the gross column. That's what it says, median gross revenues. That's the gross column. And we want to find the median of this. This actually says 10,000 or less. So really I need to do less than or equal to and then call this. So that is the median gross. All right, from exercise 5, it appears that movies with more than, it says do the same for more or less. So we need to do for both. And let's copy this. And really this should come first. So this is more, this is less. Okay, so the movies with more have a little higher median. Maybe that makes sense because they have more likes. It appears that the movies with more than 10,000 total Facebook likes gross 2.5 times as much. This may be due to the fact that newer movies have more actors that are recognized by Facebook users. So it doesn't mean that these are just going to be better performing movies. It could just be that they're newer movies and they were made in a newer time period where there was just, the money is worth, because of inflation, money is just more for the revenue. Okay. This may be due to the fact that newer movies have more actors that are recognized by Facebook. Find the median year produced by both groups. Okay, so this is interesting. So we should actually call this maybe filt 1 and then filt 2. So now we will say we need the year, the median year. So here we'll do filt 1. So this is the ones with more actor Facebook likes. So let's get the median of the year. So it's 2006. And the other one is 2005. So there's not much of a difference in the year. This one is just 1 year older for the median than this one. Number 7, for each movie made in the year 2016, what is the median of the total actor Facebook likes? Okay, so we need to get a filt such that the year is 2016. And let's quickly just look at this. So we get one result over here. And not movie, we need to do the actor Facebook like ones. Okay. So here is this. So these are just the ones that are made in 2016. And now we're going to sum up the total to get the total like this. So we're just doing the sum, axis equals 1, and then we're going to take the median, and that is the number. Write a function that has a single parameter year. Have it return the median of the total actor Facebook likes for a given year. So we're just going to use this code over here. Median Facebook likes. It's going to get the taken the year. And instead of exactly 2016, we're going to say year. And we will just return this like this. Okay, so let's verify that our code works. There's 2016. We should get the same number. This should say exercise 7. All right, number 9. Write a loop to print out the year and median total actor Facebook likes for the years from 1990 to 2016. All right, so we have this function. This is the whole point. So you can say for year in range 1990 to 2017, we will print this out. We'll just print out the year and also the result like this. So that's how you can do it. All right, we're going to use the college data set for the remaining. We've put the institution name over here. Find the number of non-missing values in each column and again for each row. Okay, so the count method is exactly what does that. This is the number of non-missing values. Right, so some of these have quite a few missing values. And then we want to do it for each row. We want to go the other direction. Right, so some of these colleges have very few non-missing values. Right, so this, you have to know the number in your data set. Right, so there's 26 columns. So these at the top have either all non-missing values or they're all accounted for. There's no missing values in these one except for this one actually. All right, number 11. What is the average number of non-missing values for each row? So we're just going to take this series and we're going to calculate what is the number of non-missing values. Is the mean like that. So on average, there are 22.7 non-missing values. The UGDS column of the college data set contains the total undergraduate population. What is the least number of colleges it would take to have a total of more than 5 million students? All right, so this is a little complex. So what is the least number of colleges it would take to have a total of more than 5 million students? So what we need to do is actually get the UGDS column, and we can sort this from greatest to least. And then we can take the cumulative sum of this. So we need to continue to accumulate this until we get to 5 million like this. So how do we determine if we've reached 5 million? Well, we can just test this over here. We can say, we can assign this to S, okay? This is like a multi-part question. We can't easily answer this in just one. And then we could see, all right, when is this less than 5 million? And you can see here that, all right, so by the time we get to 184 colleges, we will get to just below 5 million. The next one would put us over the top because this is already sorted, and this is the cumulative sum. Remember, so it's accumulating all the undergraduate student population from all of these colleges above here. So you would say that it would take 185 colleges. You take the 185 most populous colleges, add up their add up their values, and you would get over 5 million. So another way of determining this is we could say UGDS n largest 185, since we know that this is the 185 largest ones. We do dot sum on this series and we get just over 5 million. If we did it on 184, we would get just under 5 million. All right, call the describe method, but make it only work for string columns. So we learned how to do exactly this. We say include equals object like this. Number 14, call the max method, but only return numeric columns that are numeric. Okay, so we have to call the max method. I'm going to say numeric only equals true. And we'll get this. So a lot of these columns are 0 and 1s. That's why you get this data over here, or just percentages. These are percentages by race. All right, that's it for the exercises.